No headlines, no breaking news, no sirens or viral videos, just a quiet sentence in a technical report. Energy amplification confirmed. Feedback loop sustained. Duration 4.6 seconds. Most people skipped it, but for a few physicists, that single line could have changed the world. A theory once considered impossible, the black hole bomb, may have just become reality. It all started in 1969. Physicist Roger Penrose proposed a wild idea that a rotating black hole could be tapped for energy, not by touching it, not by falling in, but by using its spin against itself. He imagined a particle entering the ergosphere, the twisted region outside the event horizon. If that particle split and one part fell in, the other could escape with more energy than it started with. It sounded insane, but the math worked. Then, a new twist. What if instead of particles we used waves? And instead of escaping, they kept bouncing back and forth. Each bounce would steal a bit more energy from the black hole's spin. If trapped inside a reflective shell, a perfect mirror, those waves could grow, indefinitely. A self-sustaining energy loop, a theoretical bomb. Too dangerous, too abstract, no real black hole, no real mirror, just science fiction, until now. In 2025, deep beneath a mountain in Switzerland, a research team called the Ether Group built something. They called it the Ether Array. No black holes, no mirrors. Instead, spinning electromagnetic fields and a plasma shell. A simulation, a controlled replica of the conditions needed for superradiant energy amplification. They initiated the system with a prepared energy pulse. At first, nothing unusual. Then the third bounce came. Energy increased. Fourth bounce, it doubled. By 4.6 seconds, the system was feeding itself, just as the theory predicted. Then, they shut it down. Not because it failed, but because it worked. They weren't afraid of an explosion. They feared what came next. Because the system wasn't chaotic, it was controlled. Smooth, efficient, exponential. That terrified the team more than failure ever could. This wasn't like a nuclear chain reaction where instability is expected. This was precise. And with each cycle, the system fed itself faster. If they'd let it run to 6, 8, 10 seconds, what would have happened? No one knows. And that's the scariest part. Since the test, no press release, no headlines, just a quiet academic paper with a vague title. But those who understood everything. Private labs started building their own ether simulations. Defense analysts began speculating. Could this disrupt satellites, power grids, entire systems? Not with brute force, but with invisible resonance. A weapon that leaves no trace? Others saw potential. Clean energy, new propulsion systems, even fundamental physics. Isn't it the thing that scares scientists the most, that it explodes? It didn't. It was elegant. It was predictable. It was silent. If something can grow forever, when will we stop it? Worse yet, will we want to? Let us know what you think in the comments.